Hello everyone. Welcome to my first video about the value at risk and the expected shortfall. Um, in this video, I just want to show you how you can compute these two factors, so the expected shortfall and the value at risk, and also in two different ways. First of all, there is the historical data approach. And second of all, there is the simulation approach. And yeah, with the first approach, we just look at historical daily returns and estimate the value at risk and expected shortfall on the basis of these historical returns. But of course, these historical returns aren't a guarantee for the future, and that's why people sometimes also use simulations, which can generate a model for future stock returns rather than looking at historical returns. So let's have a look at our Excel sheet, which looks like this. I also want to mention that this video is purely made to show you how to compute these things in Excel. So if you're interested in the theory behind it, then I would recommend you to search for something else. So yeah, this is our Excel sheet. Here on the left side, you see some data I've downloaded. In the first column, you see the dates I've downloaded, which run from the 1st of April of 2014 to June 2015. And in the middle column, we see daily returns of this stock, which is called Ahold Delhaize. It's the mother company of different retailers in the Netherlands, but that aside. Um, and if we begin with the first estimate, um, which is the value at risk with the historical data approach, then the first thing we want to do is sorting these daily returns from smallest, these daily returns from smallest to largest. And we can do this on the following way. You just want to copy this section by entering Control Shift arrow down. You copy it and then paste it right here. Then we have to select this column in the same way with Control Shift and arrow down. And then we go to sort, and then you see sort smallest to largest, and continue with the current selection. So sort, and now the daily returns are sorted from lowest to highest. And so now these daily returns don't correspond to the dates anymore. And why do we do this? We do this because we look at different confidence intervals, uh, like these confidence intervals. So, for example, if you look at the 95% confidence interval, you want to look at the 5% worst outcomes of this sorted column. And it's the same for a 99% confidence interval. Then you want to look at the 1% worst outcomes. So how do we compute the line of this percentile, the line of this percentile, or the value of this percentile, which is called the value at risk? Actually, it's the 1 day value at risk because we look at daily returns. Excel has a function for this, which is called percentile dot inc. Parentheses open. And if we want to fill this function in, then we do this as follows. We first select the whole area of the sorted daily returns. So this area. And then we put in the percentile. So the 1%. And then we close the hook. And then you enter. And then we have our value at risk. However, in practice, most of the time we compute the value at risk as a monetary number. And if we want to make this value at risk a monetary number, we first need to know how many we want to invest in this certain stock. So let's say we want to invest 200 euros. So our stock value is 200, and then we make it euros, 200 euros. So our stock value is 200 euro. And in practice, the value at risk also most of the time is a positive number. So we want to make the value at risk positive and monetary. And we can do this in the following way. You can put a minus sign before the percentile dot inc. So like this. Then you have to put an extra parenthesis here. And after that, you have to multiply the whole formula with the stock value, this stock value, which is your investment. So times this stock value. And then you can enter, and then it doesn't work. Why doesn't it work? I already found the mistake. We don't have to multiply it with H14, but with this value, the 200, of course. I14. And now we enter, and then it still doesn't work. And why is this? Ah, now it works. So now you have the value at risk in monetary positive terms. And this value at risk means that there is a 1% chance that the next day you will lose €7, 19 or more. And you can do the same for the other percentiles. So for the 5% percentile and the 10% percentile. So let's do that. Is percentile dot see, and then we put a minus before it. Open parentheses, array, whole array. 5% percentile, close parentheses, and again, and times G investment. No, this investment. Ah, I14, yes. And then we have this value at risk, which means that the next day we have a 5% chance that we lose €3, 31 or more. And again, we can do this for the 10% confidence interval. 90% confidence interval. Open parentheses. This. Ah, sometimes. Control Shift down arrow. And then this percentile. Close parentheses 2 times. And times this value. All right, and then we have this value, the €2.60, which means that at a 10% level or 90% confidence interval, there's a 10% chance that we lose €2.60 the next day or more. So that's the historical data approach. You can also do this with the second method, which is the simulation approach. If you want to do a simulation, you first need to make the simulation itself. And we need to make a replication which contains enough observations. So let's say we make a replication of 1,000 observations. So yeah, we rank it from 1 to thousands, and we can do this like this. There is a better way, but um, I do it like this. All right. And if we now want to make a normal distributed simulation, we first need the mean and the standard deviation of our historical returns to make the simulation representative. We can do this by simply filling in. So here we want to compute the average of the historical daily returns. And we can do this by simply filling in is average and then selecting uh, this whole area. Close parentheses, enter. And the standard deviation, we can compute it by filling in is STV dot S and then selecting this whole area. Enter. And now we can make the simulation with the following formula. We put it in here. The simulation is norm dot inverse open parentheses. Then we have to which makes the simulation change each time. So we fill in random, and then we put in our mean, which we have just calculated. So we put in this value, and we put in the standard deviation, which we have just calculated. So now we close parentheses. And if you're smart, you also put in a dollar sign because we're gonna copy these values down. So that's very useful to put in a dollar sign, and then we hit enter, and yeah, there's your simulation. So now we got a value which we can copy down. So there we go. And if we now go to calculate now, we see that these values will keep changing. And this is the simulation. And now again, if we want to get the value at risk of the simulation, we use the percentile dot inc formula. So here we have the value at risk for our historical simulation, which is this simulation which we have just made. And again, we just use the percentile.inc formula, and we can do this if we want to make positive terms. We do this like this. This percentile. Let's see. Open parentheses. We choose our array, which is the whole column. Right, and then we choose our percentile. And close parentheses again, and we multiply it with our stock value. And now we have our value at risk, in the right terms, so in positive monetary terms. And we can also do this for the 5% level and 10% level again. So is stock value. Is so yeah, that's our value at risk with our historical simulation, and you see that these values keep changing because yeah, that's the point with the simulation. We've put in the random, which makes the simulation keep changing. All right. Well, if you want to compute the next value, the expected shortfall, you can also do this with two approaches. First, we look at the historical data approach. With this approach, we will have to look at our ranks, which we just made, so these ranks. And with the expected shortfall, we look at the expected value which would come true if this 1% percentile holds, for example. So we can do this simply by using the ranks and getting the average until that rank. So yeah, like I said, you want to compute the average of, for example, the 1% worst possible outcomes. And for that, we use these ranks. This sounds a little bit abstract, but let's have a look. If we want the expected shortfall at the 1% level, we want to look at the average or expected value of the 1% baddest outcomes we could have. So if we want to know until which rank the 1% baddest outcomes are, we firstly need to know how many observations we have at all. So firstly, we put in number of observations of our sorted column. And you can do this by putting in the formula. So here, number of observations. And you can do this by putting in the formula is count and then selecting the whole column of sorted. Enter. Once we've done this, we now want to know what 1% of this 326 is. And we can simply do this with our calculator. And then we see that 1% of 326 is 3.26, of course. This means that the 1% baddest outcomes, these 1% baddest outcomes are until rank 3 because we round down. So that 3.26 we round it down, and that means that until rank 3, uh, these are our 1%. So these three are our 1% baddest possible outcomes. And now we can simply take the average of the first three values by putting the following formula. First, we divide the 1 over the 3.26. And then you want to multiply this with the sum of the first three values. So times the sum of the first three values, because we want to get the average until rank 3. So these first three values. And in this way, we can get the average of, like I said, these three values. But we also want to make it a positive monetary number. So we put a minus sign before it and multiply it by our stock value. So open parentheses, put a minus sign before it, put an extra closing parentheses, and then we multiply it with our stock value here, and then we put enter, and we see that we have a expected shortfall of €11.40. It gives you a error because you didn't select the whole column of the sorted column, but you then just have to ignore the error, and yeah. And we can also do this for the other two percentiles. With the 5% percentile, we first want to know what 5% of 326 is. So you get your calculator and just put in 0.05 times 326, which gives you 16.3. Which leaves us with the 16th rank. So with the 5% percentile, we want to get the average of the first 16 worst possible outcomes. And again, we do this by, first of all, is dividing 1 over 16.3, which you've just calculated on your calculator. And then you want to multiply this with the sum of the first 16 worst outcomes. To this one. Then you close parentheses. And of course, you want to make it again in positive monetary numbers. So we put a minus sign before it and multiply it with our stock value. So times stock value. And then we get the following expected shortfall. And also here we ignore the error. And here we do the same. 10%, of 326 is 32.6, which we round up. So we go until rank 33. So again, we put in is 1 over 32.6 times sum 1 until rank 33. So that's here. Yes. Close parentheses. And again, we want to make it positive monetary terms. So we multiply it with our stock value again of €200, our investment. And then we get the following expected shortfall. So in this way, you can compute the expected shortfall on the basis of historical data. And yeah, that only leaves us to compute the expected shortfall using the simulation. So this column. However, for me, a problem occurred during getting this value, which is that I couldn't sort the simulation from smallest to largest. And this made it very difficult, or actually impossible, to use the ranks on the right side. Um, so I had to figure out something else, and I also found something. I found a formula which automatically picks the smallest values from the simulation, just like the percentile.inc formula does. And yeah, I don't want to dive too deeply into this formula. But if you want to know how this formula works, then I would recommend to have a look at the formula, well, step by step, or just Google it. And if you also want to use this formula, I will put it in the description down below. So you can copy and paste it for your project or something else. But there's only one thing, and that is that if you want to use this formula, you will first need to get the historical value at risk in not monetary terms. So here we have computed the value at risk with the historical data approach, but in monetary terms. And if we want to use the formula for the expected shortfall with the historical simulation, we first need to make a column with the value at risk with the historical data approach, but then in non-monetary terms. So we can calculate it right here. And of course, we now know how to calculate the value at risk with the historical data approach. So non-monetary. We can leave this white. So we do this by just putting in is percentile dot inc and then choosing the whole column again. And choosing this percentile and then enter. And we get this value at risk, this non-monetary value at risk, which is good. Then again, percentile dot inc. We choose this whole column again, but we use another percentile, which is 5%. Enter. And last but not least, for the 10% percentile, right? Again, 10%, 10%, close parentheses. And now we have these value at risks in non-monetary values. So now we've done this, we can take a look at our formula, which goes as follows. This is the formula. And what's important about this formula? First, you uh, have to make this, get away these commas and put in a. And what's important about this formula is that this part over here, these two parts, these blue parts, they are about, they entail your whole simulation. So this is the range, and this is the range of your whole simulation. And of course, this could be something else at your Excel sheet. But for these two parts, you just have to select your whole simulation range. Furthermore, these two M3s are about the non-monetary value at the non-monetary value at risks in this column. So for each row, we have a different M. So for the first row, we have a M3, but for the second row with the same formula, we use another M3, M. So we use M4. And the fifth row, we use M5. And last but not least, we of course want to make it a positive monetary value. So at the end, that's this thing over here, we multiply it by our stock value, which is wrong in this formula. Our stock value is Y14, like this. Right. And of course, we want to put, if we want to make it positive, we have to put this minus sign before the formula. And well, if we hit enter, then we get this value. And if you go to calculate now again, you will see that this value keeps changing, and that this value is very close related to to this value, to the expected shortfall with the historical data. And that this value, the value at risk with the historical simulation, is also very close related to the value at risk with the historical data. So that's the difference between the simulation and the historical data. And yeah, we can also do this, of course, for the other two percentiles. So then you can simply just copy this formula. Oh no, wait. Then you can again, paste this formula. But then you want to change this M3 to M4 and this M3 to M4 because you want to select, yeah, you can't see it right now, but you want to select, oh, and again, you want to change, no. Again, you want to change these commas because Excel doesn't recognize them. Put in a point comma. And for the rest, everything stays the same, I think. So yeah, and now you put enter again, and then it doesn't work. Oh, because we have to multiply it with by 14 with our stock value. So yeah, for this formula, we don't use the M3, but M4. And for the last percentile, we again fill in the formula, paste the formula. We first want to change this. Again, these commas need to be wiped out. And now we don't put in M4 or M3, but M5 and M5. And we hit enter again. And then we got this value, which is a little bit weird. Oh, it's another. Yeah. Okay, it doesn't matter. And if we hit calculate now again, you see these values keep changing. And yeah, that's basically it. So now you have calculated these two values in actually two different ways for each value. So that leaves you with 4 different outcomes. And yeah, I would say thanks for watching. And if you liked this video, don't forget to hit those thumbs up and subscribe to this channel to give me yeah, more motivation for making these kind of videos. So yeah, thanks for your attention.